Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all the panels present here today. My name is Muhammad Ibn Hassan, and I am a third year Akabatu student who is doing his FYP under the supervision of Dr. Ko Wai Ho and my co-supervisor Dr. Siti Ariza binti Arifin. My project title is Effects of Temperature on the Embryonic Development and Survivability of Larvae on Mud Crab Silau Livasia. Silau Livasia is commonly known as orange mud crab, and it differs from other Silau genus due to the lack of polygonal structures and due to its color, which is ranges from orange to brown. It is mainly found in mangrove waters and estuaries. So, my research background mainly revolves around the concept of the impact of climate change towards marine life, and for my case, mud crabs. Because recently there was a future projection made by IPCC that stated that at the end of this century, the global ocean would experience an increment of 4 to 6 degrees Celsius. So why is this problematic? It is a problem because invertebrates, such as mud crabs, are ectotherms and they cannot regulate their own body temperature, which means that every single changes in the environment would cause some impact towards their well-being. As stated by many papers, stated that increasing temperatures would threaten the health of crustaceans and also towards their larvae or their offspring, which would cause deformities and increasing the mortality rates. So my objective is to evaluate the effect of climate-induced temperature increase on the embryonic development of mud crab Silau Livasia, and to assess the effect of climate-induced temperature increase on the larval hatching rate. For my experiment preparation, after I received all my broodstocks, I recorded their morphometric measurements and then I disinfected them inside a 150 parts per million formaldehyde solution for 30 minutes before transferring them and acclimatizing them inside a 10-ton tank. Right after that, I will start feeding them for 3 to 4 days before I start eye stalk ablation. I did the eye stalk ablation so that I could expect when the female mud crab would start to extrude their eggs, which is 2 to 3 weeks after eye stalk ablation. So when the female mud crab extrude their eggs, which it becomes a buried female, I take two important data, which is the weight of the buried female and also the sampling 0.01 grams of eggs. This is used to calculate the fecundity later on. After that, I allocated them inside their own respective tanks, which is 29 degrees Celsius or 33 degrees Celsius. And each day after that, I would sample a certain amount of eggs from each buried female to observe their yolk consumption rate and also to measure their egg diameter. After the female crab extrude the egg or the eggs have hatched, I would then weigh again the female mud crab so that I could calculate their fecundity. After that, I would do a volumetric sample analysis at 3 different depths so that I could calculate their hatching rate. So this is some of my pictures during my experiment. For the data calculation, these are some of the formulas that I've used in my experiment to calculate the fecundity, hatching rate and yolk consumption. For my statistical analysis, I use normality test and t-test. And as you can see, my result, it says that I found significant difference for the egg diameter and yolk ratio between the two treatments. However, I didn't find any significance between the hatching rate and fecundity amongst the two different treatments. And this is the embryonic development stages for the 29 degrees Celsius. As you can see, it took them 9 days to reach the pre-hatch stage. Meanwhile, for the 33 degrees Celsius, it took them only 5 to 7 days for them to reach the pre-hatch stage, which is the last stage before they hatch. So, according to my result, yes, there was significant difference, and the higher temperature actually gives a faster embryonic growth and it hatches faster. And this is because of the temperature itself, as stated by some papers. However, faster doesn't mean it is better. Faster embryonic growth would increase the probability of molt death syndrome, which is the interval between, let's say, ZOA 1 to ZOA 2. During the molting molting period, it would probably die during that intermolt period. And also, the period of time needed for the larva to reach megalopause stage is prolonged in temperatures above 29 degrees Celsius, which makes them susceptible towards temperature change and also will increase their mortality rates. So, in conclusion, yes, when the temperature increases, the embryonic development rate and hatching rate increases. However, there is a catch. According to several papers, the growth rate during larval stage will decrease and would probably cause MDS in higher temperatures. So some of my recommendations to solidify or to gain a concrete result in the future is that for the fecundity and hatching rate, I need to make a control sample that is not interfered at all by humans, because every day for my experiment currently, I need to sneak a bit of their eggs to take the egg samples. So this would cause them stress, and it would extrude some of the eggs every day. So it would gravely impact the data for the fecundity and hatching rate. And lastly is that I need to do further studies to examine the deformation and survival rate of larvae at higher temperatures. And I think that's all from me. Thank you.